Good morning, all. Myself, Dr. Praveen, Associate Professor, School of Computer Science and Artificial Intelligence in SR University. Now, today, I'm going to explain DBMS concepts. That is actually the first unit is mainly focused on the DB database and DBMS. What are the traditional databases and what are the modern databases? And data models, and the relational model, NoSQL, key values, and next one is the document-based, column family, and graph-based. These are all the data models. Okay, earlier we discussed only relational model and NoSQL. Okay, next third concept is hierarchical and network models, historical context and limitations. Okay, next one is fourth concept, database system, architecture, centralized and distributed databases. And last one is cloud databases. So we want to start with the what is database, introduction to database, and introduction to information management system, and what are the advantages, what are the disadvantages, we will discuss. Now the main outcomes of this course is understand the principles and concepts of modeling database systems, and apply queries using SQL for effective data management. And third outcome is analyze consistent database structures and effective recovery mechanisms. And fourth outcome is analyze various database management systems. These are the outcomes of DBMS. Now coming to introduction, see, this is the introduction concepts. Now what is database? Why we learn the database? Right? Software-based systems to collect, manage, and distributed information with organized for the organization. See, the DBMS is a database, is a collection of interrelated data. Now this data is reside in memory in organized. That is called the definition of the DBM database, and provides timely, accurate access to data for informed decision making and coordination and controlling. Okay, when we are access the data within the time period, within the nanoseconds or milliseconds, we accept this data, access the data with accurate results. Right, that is the main introduction. And why we learn IMS? IMS stands for Information Management System. Okay, without IMS, the number of errors are increased, and it will take time. Okay, it will take more time-consuming task. Inconsistent data management. Okay, inconsistent data management means we have 2 or 3 files. In these 2 files, one file is the main file, other files are the dependent files. If you want to change the content in the main file or one file, that will be reflect in the other files, but that is actually consistent. Without DBMS means earlier we have a file system. In file system is a inconsistent data management. So if you want to change something in one file, that is not reflect in other files. That is called the inconsistent data management, right? And IMS provides, information management provides multiple users support. Okay, actually this is the main objective of DBMS. So here we have many users are there. The many users or multiple users are access. So for example, this is represented with this is the database. These are all the users. Now these are all users are accessed at a time. So at a time. So in this scenario, we access accurate data. And advanced queries here we have. Now, what are the advanced queries like joins? We have to join 2 or 3 tables, and we provide a strong security to ensure data integrity across industries like banking, healthcare, and e-commerce. So, integrity constraints. Integrity is important for access the data in various fields like banking, healthcare, and e-commerce, right? These are the main things for using the IMS, information management system. Okay, one is the without IMS, there is no many errors are there. There is no security, and it will take more time. The error rates also increased. So the IMS provides the security, multiple user support, and provide the queries and strong security provide using the integrity constraints with various fields like banking, healthcare, and e-commerce. Now, key functions of IMS. What are the already we learned what is the importance of IMS. Now, key functions of IMS. First one is the gather the this is the gathers diverse data, example documents, transactions, sensor feeds. So this is the IMS. Now here we have a IMS. This is the IMS. These are all the key features of IMS. These are all the key features of IMS. So data storage. Okay, saves data in structured database or cloud repositories for long-term uses. Okay, here we have to store the data, right? Now, for example, in singleton systems or servers, or we store the data in cloud repositories. Next one is we collect the data from various different data like Word database, Word documents, transaction database, sensor feeds. Like presently, we all use the IoT. So IoT by using sensor feeds, we store the data and processing. How to process the data? Transforms raw data into actionable processed information. We know what about the raw data here. Raw data that is called metadata. Okay, this metadata is converted to the information like actionable data, like our processed information. Right. Next, distribution. How to distribute data from one system to other system or one field to other field. So distribution shares customized reports with stakeholders via dashboards, reports, or alerts. So, customized reports, we have to gather the data and process the data. After processing, we create a report. That report is shared to other person. Now, how to access? Ensure appropriate access controls and fast retrieval based on the user roles. So, coming to here, this is the first one is the data storage. We store the data and search retrieval. We have to use some searching concepts. We access the data from the data storages and collaboration tools. We have to collaborate one tool with other tool, like that is called one is Java, other one is Oracle is connected, and next document management. Okay, the documents are reside in the databases, and we have to integrate one document to other document or one model to other model. And next one is the workflow automation. Okay, these all are the key functions of the IMS. Okay, simply you remember, first you gather the data and we store the data and process the data and share the data and you access the data efficiently. Right? This is about the key functions of IMS. And now, data refers. What is data? Data is a unorganized facts and figures that do not have meaningful meaning on their own. It can be numbers, characters, symbols, or images, or even sounds. So the data is unprocessed or unmaterialized data. Unmaterialized. So for example, my number is my mobile number. Actually, I want to write here like 988401731. This is my mobile number. Now here, actually, we did not mention anything. Just I want to share 9885401731. These are all the numbers. There is no meaning. Okay, now this is called the data. This is unorganized fact. This is unprocessed, unmaterial. Okay, this is the raw data. Raw information is called a data. Right example here, 100 comma 90 comma 85 comma 75. These are all the numbers. And example 2, we have a John 2005 M. This is a combination of characters and numbers, but there is no meaning. Now we write like this. This is processed, and the processed means information is a processed or it is a organized, right? It is a well structured data. Sorry, well structured data that has meaning with the proper context and making it useful for decision making. See, this is a not meaning. There is no meaning on data. There is no meaning here. But now coming to here, we have a meaning. So now we want to write like Praveen mobile number is 9885401731. Now this is called a meaningful statement or sentence. You observe. This is the so now 9889885401731 is a mobile number of Praveen. This is the meaningful statement or meaningful sentence. Now coming to our one example, previous example 190, 85, 70, there is no meaning, that is a numbers. Coming to here, example 1 is information is a meaningful data. Information is a organized, information is a processed. So now I want to write like this. Student scored 100 in math, 90 in science, 85 in social, 70 in English. So this is the meaningful statement. Now example 2, John is 19 years old, male, born in 2005. So it is a meaningful, but coming to previous example, John 2005, M is not a meaningful, but this is the meaningful statement. So now the data is unmaterialized, unorganized, right? And that is matter. But the information is organized, processed, materialized, and structured, well structured. This is the difference between data and information. Now, coming to databases, what is database? So, database is a large collection of related data that can be stored, generally describes activities of an organization. Simply, you remember, database is a collection of interrelated data. We store the in data repositories. The characteristics of the data in databases. Now, the first characteristic is a shared. Data is a shared. Data is a persistent. Data is a correctness. Data provides security. No redundancy. These are the characteristics of the database. So, one is the data in a shared. Now, what is shared? Data in a database are shared among different users and different applications. Okay. Now, previously we discussed multiple users access the data at same time. So one user can access at the same time, other users also access the data. Now, sometimes we have to store the data from one user to other user. That is called the sharing the data from one source to other source or source to destination. And persistent data in database exists permanently. Okay, actually, the main objective of computer is we have to store our important information permanently reside in the database of memory. So now the persistent is data in databases exist permanently. Permanently means okay, there is no temporary. Okay, whenever you want to the data, then you can access, then you can retrieve the data. Correctness. Data should be correct. Always data is a provide the correct values. And security, how to provide the security. Data should be protected from unauthorized users. Who are the unauthorized users? Okay, whenever we store the data, suppose I want to store my information in my database. Now I am the authorized user. I have some credentials like username and password. And someone is unauthorized. Someone want to access my data. So there is no possibility because I want to provide a security on my data. So if anyone can access, then I will give the permission to him. Otherwise, that person is not can't access the data. That is called the security. Okay, now you have to provide you have to protect the security to your databases. Next one is the non-redundancy. Okay, already we discussed about the redundancy in earlier classes. Okay, for example, you have a details. We have some details. Your details is reside in different files. Okay, one file is there. That file contains the data about information about you. Again, if you want to store about you, that won't accept. That is called the redundancy. If your data is available in two rows, so that is redundant. No two data items in database should be present at the same entity. Same entity. I want to take one example here. This is the table we assume. Next, I will explain what is table. Now here. Now this is the all ticket number. This is the name. This is the percentage we assume. Now the all ticket number is 123 XYZ, right? A percentage is 90. Now again we want to 234 PQR. Now 85. I want to enter again 123 XYZ 90. Observe here the 123 all ticket number is reside in our identity in our table twice. This is called the redundancy. Now you have to avoid the redundancy. Okay, non-redundancy means no duplicate values. Right? This is the importance of DBMS, data security, data indexing, multiple user support, efficient queries like we have a joins, we have indexes, we have a sequences, right? And data organization and efficiency, okay, and easy data retrieval. We can use the ISAM, indexed sequential access method. We have a commands in Oracle and data integrity. We have to match one entity to other entity by using the referential integrity constraints like primary keys and foreign keys. Next, we will discuss. Now, these are the characteristics of the databases. Once again, you check shared, data is persistent, data is correctness, data provides the security, right? And data is not allow the redundancy. Yeah, now the traditional old databases are called the file-based systems. File-based systems actually in main drawback in the file-based system is there is no consistency. Right, I will explain it briefly. Now, what is the file-based? What is the traditional? See, each application maintains its own data file, leading to the fragmentation. What is own data file? So there is no integrity. There is no interdependency. Okay, this is file one, this is file two, this is file three. All are the standalone. All are maintained individually, right? Suppose this is student file, this is employee file, this is the department file. Now student data is reside here, student data is reside here, student data is reside independently. When you are enter the student details in this file, that is department file, that will be reflected in all files. That is called modern databases. Now in traditional databases like file-based systems, all our data files are independent. and manual update across multiple files increase the risk of the inconsistency. Uh, Actually, these data files are inconsistent because if you want to change student details in student file, that is not reflected to the other files because this is independent, and this is independent. So now the manual updates are required, right? And next one is the risk of inconsistency. Because suppose here we have changed the hall ticket number of the student. This is different. Here, this is the employee. Okay, there is no relation, but employee to sorry, department to student is related. So department table, department entity, the details are different. Student details, but student table, student details are different. So that is called the inconsistency. And next one is the about no unified querying capabilities. Reporting was slow and cumbersome. So here there is no proper queries to retrieve the data, to update the data, as well as to delete the data. So that's why the system will be slow and minimal security. Now, in modern databases provides high security, but traditional databases provides the low security. That is, anyone can access the file and could modify and corrupt the data because here the unauthorized persons also access the data. That is the main drawback in the file-based system. And lack of audit trails. Okay, lack of audit trails means the logging systems. Okay, enabling hard to trace errors. Okay, avoid the errors are also not easy. Right? Examples are ISAM, VSM, and IBM's IMS and CodeSys DB. These are all the examples of the file-based systems. Presently, everyone is using the modern-based systems, only modern-based databases. Okay, this is about the traditional. Next one is the modern-based databases. Coming to modern databases, early DBMS addresses limitations of the file-based storage system. What are the limitations of the file-based system? There is no security, there is no consistency, and there is no unauthorized access. Unauthorized persons can access easily. These are all the problems in the file-based system. DBMS separates data storage from application logic and enabling better data management system. And it's provide the logical view of data, making it easier for users to interact with the databases and ensure transaction reliability through the asset properties. Okay, asset properties, atomicity, consistency, isolation, and durability. Now, these are all provided in the DBMS, enables concurrency control in multiple users environments to prevent data conflicts. Okay, now the main advantage to use the DBMS is multiple user accessing. So we can access at a time, right? And support data independency, allowing the schema changes and affecting existing applications. Now you observe the taxonomy of the databases 1960s, 1970s, and 1980s, 1990s, 2000, and 2010. So now, DBMS technologies and relational empire, relational databases, multidimensional database, and 2002 graphs, and presently from 2010 to nowadays, we are using the NoSQL. These are all the modern databases and types of traditional databases. We have two types of traditional databases mainly. That is called the one is the hierarchical, another one is the network databases. The hierarchical model organizes data in a tree-like structure with a single root and parent-child relationship. Now, this is called the hierarchical model. So, you observe the definition, observe the example. Shoes is a root node which contains the two leaf nodes, that is the two child nodes, women shoes and men shoes. Women shoes again divided again contains two subcells, two leaf nodes like two cells like high heels and bellies. And men's shoes we have sports shoes and sneakers. So one entity, this is one file. This file is belongs to this one. This file is belongs to this one. Okay, this is called the hierarchical architecture organization. Okay, tree-like structure. Right. And coming to network layer. Now, network layer, this is the network. First node is a college, first entity, or node we called as node or entity. Now, college, we have two departments. One is the CSC department, another one is the library department. Now, the student is belongs to department CSC as well as is taking some books from the library. So this is the one to many relationship and many to many relationship. Mainly many to many relationship. So now CSC department is connect with the college and connect with the student. Okay, and the library is also connect with the college and connect with the student. Student is connect with the CSC and connect with the library. So this is the many to many relational. The network model expands on this by allowing more complex M to N. M to N means that is called the many to many relationship, where a record can have multiple parents and children. Now CSC having okay, a student having two chairs, two parents like CSC department and library. So this is called the traditional databases. Okay, one is the hierarchical, another one is the network databases. And limitations of the traditional databases. Already we discussed data redundancy and inconsistency and lack of data integration, difficulty in accessing the data, poor data security, no concurrency control, limited data sharing, and lack of backup and recovery. Okay, now these are all the limitations of the traditional old databases. First one is the data redundancy and inconsistency. See, data redundancy means the same data is reside multiple times. Inconsistency means if you want to change data in one file, that is not reflected in the other files because all files are the independent files. All files are singleton. Lack of data integration. There is no integration. There is no interrelation between one file to other files. And when we are access the data, it is also difficulty because there is no proper key constraints like a primary key like that. If you have a primary key, then we can access easily by using the primary key. And poor data security. Unauthorized people can access easily and no concurrency control. Okay, no concurrency control means whenever the multiple users are access the data, then the conflicts will be raised. And limited data sharing. Data sharing is very limited, and backup is very bad, and recovery is also bad. So these are all the disadvantages of traditional DBMS. Okay, this is about the limitations or disadvantages of the traditional database management system. And modern relational DBMS. See, observe here. In modern relational DBMS means relational model means which contains the rows and columns. So the modern databases, see, observe here, the relational model provides a logical and declarative way to handle data, separating physical storage concerns from how users interact with the data. So here the customer table is there. The customer schema is table schema is customer ID, first name, last name, phone, and country. Now we have to store five records. You observe here five records. Now the customer ID is in customer ID is here unique ID and the phone number is also unique and now name last name country. Okay, this can be this will be accepted duplicate, that is not a problem. But coming to customer ID and mobile number, both are the key constraints in this relation. Structured query languages, SQL, already we know SQL. Okay, it becomes a standard for the querying, updating, and managing relation databases. So when we are create the table, we store the data by using the insert command. By sometimes we have to update the data by using the update command. Sometimes we have to retrieve the data by using the select command. Modern relational databases systems like Oracle, MySQL, PostgreSQL offers robust transaction management, indexing for faster retrieval. We have to follow the indexing and stored procedures, triggers, and extensive support for data security and backup. These all are the modern databases tools or advantages. Applications where we are using the modern relational databases that we'll use in the educational institutions and banking and chit funds and various departments we can use the modern relational databases. Now, manage student information. For example, education institutions. Now, what are the fields we have here? Managing the student details, attendance, we take the attendance, we give the results, and we enroll the course details, and generate the report cards and performance analytics, and backup every time, every day we have to store back of the databases to prevent the data loss. So this is about the relational databases and the rise of NoSQL. Rise of NoSQL. Okay, NoSQL stands for no structured query language. Right? This is handle the large volumes of semi-structured, uh, unstructured. Actually, structured query language is a structured data. It can handle the only structured data. Sometimes our data is semi-structured. Sometimes our data is there is no structure. In this situation, we go for the no SQL. NoSQL databases are flexible, horizontally scalable, and distributed by design. So they include the main things are there here: key stores like Redis, document stores like MongoDB, column family like Cassandra, and graph databases like Neo4j. These are all the four different tools for NoSQL. These systems can sacrifices some consistency for the performance and scalability in scenarios like recommendation systems, real-time analytics, and content management. So what is NoSQL? So high scalable, high availability, and a big data capability, fast performance, and easy replication. This is the not a structured query language. Simple, you remember. Structured query language can handle the structured data, and NoSQL can handle the any data like semi-structured or unstructured, okay, or structured. It can be handled any type of data. That is the NoSQL. And we have small example here. It is the give a student and blank paper, and this is some small task. Now draw the timeline showing the evaluation, cloud DB, network, relational, and flat files, NoSQL, hierarchical, and arrange these all in a order. Now, which database do you think WhatsApp, Instagram, and Amazon uses and why? This is the timeline challenge for the first session. Okay, this is about the introduction of the DBMS. Okay, next one is the features of the DBMS: data abstraction, data independency, efficient data access, data integrity and consistency, data security. Next one is the concurrency control, backup and recovery, data sharing, reduce data redundancy. These are all the future trends of our database management system. Okay, next we will discuss in next session. We will discuss the these all are the concepts. Now, outcome of the first session. Okay, understanding what is the DBMS concepts, compare DBMS systems with other models, recognize traditional DBMS limits, and choose suitable database model for your work. This is about the first session. Okay, thank you all. So now, first session we have it. Go to the first. Yeah, now this is the understanding principles of the concepts of modeling database system. Okay, first we completed introduction, why IMS, and key features of IMS, and data refers what is data, what is information, differences between data and information, and databases, what is database, right? And what are the characteristics of the database, and what is the file based system like traditional, and what is the modern databases we discussed, and types of traditional databases, two types, one is hierarchical and another one is network, and what are the limitations or what are the disadvantages of traditional databases, and coming to modern relational databases, what is the advantage and what is NoSQL, and now small task. Thank you one and all, and next we will meet in next session, right? Thank you all.